Cool. We'll move to the next part of analysis. In this case, you would have just come across all this engine simulations, right? So you have this crankshaft which is being rotated. So I have an image on the right top just to give you a understanding of what we're talking about. So you have this crankshaft. Uh, I have only one down here, and this rotatory motion is getting changed into translatory motion due to this piston. So that is what we are trying to do down here, and we're going to see uh, the heat generation between piston and the cylinder. So as you try to simulate it, it's going to rotate, and you're just going to stop and just going to see how the temperature distribution will be. So as you do, there's this temperature distribution which change temperature changes which happens. So that is what you're trying to do, see the heat generated between the piston and the cylinder. So you have all these options, like you can hide few of the body's stuffs, but uh, in this case we're trying to understand what is the heat being generated between the piston or the cylinder block. Okay, so that's other work we would actually do again here. This is to do with the transient analysis. Another one which we would do is like a piston cam assembly. So just another insight of converting energies. So in this case, you have just consider this as a crankshaft. So this is being rotated, and when you look at this one, it's just like simulating like a piston assembly. So the rotatory motion, this would rotate, is being this cam down here would follow the path as shown, and it's gonna translate this way. So that is what you would do. You would be looking at the stress, the deformation, the pressure being developed. So ANSYS has an option called contact tool. So wherever there's a region of contact, you can specifically look at that specific region, look to understand what is the pressure or the load which is developed. So that is one good option we have in ANSYS Workbench, and we'll be doing all these types of simulations in our classes. So I just hit the part which is over this. So just to let you know that we're trying to simulate a rotating motion to a piston-like assembly, linear translatory rotating motion converted to translatory motion. Okay, so this is another stuff we would have. Moving on to a different topic, which is heat transfer. So what is that we are going to do? So ANSYS has an option called the thermal analysis. So we'll talk more on heat transfer. So there are three types of heat transfer we would come across. One is radiation. I thought of taking this simple example to help you understand the types of heat transfer. So you have a coil or a burner which has been heated, which radiates heat, and you have, let's say you have a pan with water. You're trying to boil that water. So we'll try to understand types of heat transfer with this example, simple example. So the energy is transferred by radiation. So once the burner gets heated, it's gonna give some radiation. That's down. That is one type of heat transfer. And as a pan with water is placed on the burner, you would see that there's this energy is being transferred by mass motion of the molecules. So uh, the bottom part will have the hot water shown in red, and you see this motion of the molecules going on. So that is what convection means. And as the pan gets heated, let's say uh, this handle should be insulated, but let's say both are all metals, and when you try to touch it, uh, there's going to be heat transfer going on, right? So and energy be transferred due to direct contact is what we call as conduction. So I thought of taking this simple example to explain heat transfer. A quick review again. Conduction it's a transfer of heat to direct contact and occurs in solids. Convection is transfer of heat by mixing and motion of particles. Again, remember, this is to do with it deals with liquid gases as a whole. It's something to do with fluids. And radiation is like transfer of heat by radiation, and it doesn't require matter.